Okay, so the last bit I'm going to show you on analysis is how we can look at modal analysis results in Grasshopper and start to, I guess, do modal analysis checks of the structure. What I'm going to do is just relocate all these result queries just out of the way, and I'm going to just extract. I'll just create a data component because I just want to make this quite simple for now. So I'll just place those queries away. And what I want to do is query the modal analysis. So I'm going to go to the SpaceGass solver component again, and I've got a query here which is query modal frequencies. So this component, all it does is take a load case. So, and what I'm going to do is I'm just going to do it based on this self-weight case for now. You can set up another case where you do a combination of your self-weight SDL or live load. But for now, I'm just going to drag the self-weight case into the modal analysis, and then I can bring my my result query in similar to how we did it before. I'm just going to turn off the preview of all this, of the other results we've done. Now there are a number of modal options you can set. So if I go to the solver tab again, I've got a frequency analysis options component, and this allows me to set some of the frequency options, so frequency upper bounds, lower number of modes, and the like. So I can drag that in on top of the analysis options that I've already provided, and that's really all you should need to do. So I can now run this. Again, how we were doing previously. And what this will do is it'll perform a modal buckling analysis within SpaceGass and bring those results back in. Okay, so it's performed the analysis. We do have some results here. So what I can do now is go back to the solver tab, and similar to before, there is a decompose modal frequency component. Before I bring this onto the canvas, I'm just going to internalize that output so it doesn't rerun the solver. I'll go and get the decomposed modal frequency component, and I'll drag that in. Now you can see from here, I've got 3 modes that it's run. I've got some of the periods for these, the frequencies, and some of the other ones, number of iterations, mass participation vectors, and my mode shape translations and mode shape rotations. Now, to get a visualization of the mode shapes, I'm just going to copy and paste some of the stuff I've done in a previous script. So this is a good thing about Grasshopper as well. You can copy and paste stuff that you've done from a previous script. So I'm just going to copy that and paste it into here. Find that. And I'm just going to drag my translation vectors into there. So this is a model decompose component, and that's going to allow me to get all the nodes. And you can see there I've got 153 nodes there, and I've got 153 nodes in each of the mode shapes. So I'm just going to double check and go through and make sure this is right. So you got 1, 2, geometry, motion. I don't want to interpolate the curve. Okay, so then basically what I can do is I can get a bit of an understanding. So maybe what I'll do is I'll just look at it via for the first one. So I can just look at my I guess my mode shape for the first one. I can kind of see, well, I might do a slider which allows me to do this in a bit more detail. So I can kind of see how my mode shape's working here. So it kind of looks like my first mode shape. Turn this preview off and turn this preview on. So from here I can basically see that I've got a horizontal mode shape for mode shape 1. Looks like we're getting some vertical as well. If I go mode shape 2, just turn that on. We're obviously getting an up and down mode shape here for mode shape 2. And we'll just have a look at mode shape 3. And we're getting the alternating mode shapes there, which is quite good. That's kind of, I guess, what we would expect. So that's good to know. Also know that our frequencies are reasonably high, so it's reasonably stiff. So we might only need to do that check once or once at every time we regenerate the structure. Okay, cool. So the next video I'm going to show how we can start to also integrate steel design in this process.